Welcome everybody to Algebra 1, Section 3.4, Absolute Value Equations. Now, we haven't talked about absolute value in a while, since Unit 1 to be exact, and I want to go over the definition of absolute value again, because it has been so long, and there's not really room to write it here, so I'm just going to write it in this box up here. That absolute value, the definition is that it is the distance from 0. Now, we commonly think of absolute value as far as what it does. It makes things positive. So anything that comes out of absolute value is a positive number. But the reason it does that is because it's the distance from 0. And I'm being very much so emphasizing that here because it matters a lot to today's lesson and next lesson as well, and in the future, that absolute value is the distance from 0, not just something that makes things positive. And if you don't have that understanding of the definition, today just won't make sense, and neither will 3.5 for that matter. So in an effort to want to make this make sense to each of you, I want to make sure I emphasize that it is the distance from 0. And because distance can never be negative, it's impossible for something to be a negative distance from something. For example, I can't be negative 5 feet from something, or negative 3 miles from something, or I can't drive negative 18 miles. It's impossible, even if I drive in reverse or the other direction versus north and south, or anything like that. Distance can never be negative. It can only be positive or 0, because to be 0 distance from something is to be at that thing. Now, enough about hammering on for that definition for one moment. Now we're going to go over some steps to solve absolute value equations. And so our first step is going to be to make sure that the absolute value expression is isolated. And so this means that anything that is outside of the absolute value on that side of the equal sign needs to be moved. Whether that's addition, subtraction, multiplication, division, you name it, we need to undo that so that our absolute value bars are isolated. And we'll encounter that on some future examples, which won't actually even start until the next page of notes, but we'll talk about that as well. And then step 2 here is to set the inside of the absolute value bar, so whatever's inside the absolute value, equal to both the positive and negative number from the other side of the equation. And once again, we'll be discussing this as we go through. And then our third step is to solve both equations. And so it does say both because on step 2 you're making 2 equations, and so in step 3 you have to solve each equation. You just solve those individually, very similar to how we solved compound inequalities in last section 3.3, where we just solve them as 2 separate inequalities. So here we'll just solve them as 2 separate equations and get 2 answers. And then I'm just going to cross out step number 4 actually. We're just not going to be doing that. Now, directions here, we're supposed to solve the equation, and it says write your answer as a solution set. But once again, I'm not going to have us be doing that part today. So number 1, the absolute value of x equals 2. So this is saying that whatever's inside the absolute value bars is 2 from 0. And so in order for that to be the case, there's actually 2 ways that can happen. And so whatever's inside the absolute value bars is 2 from 0. Now, it's possible, if I just draw a number line here, that if 0 is in the middle, that 2 is 2 from 0. So if x were to be 2, that would in fact be 2 from 0. I should draw it like this, 2 from 0. And so if x were to equal 2, that would be true. Then 2 is 2 from 0. But there's a whole other way to be 2 from 0, and that's to be at negative 2. Negative 2 is also 2 from 0. It's just the other direction is all. And so negative 2 is still 2 from 0, thus x equals negative 2 is also an answer, because we're saying that as long as x is 2 from 0, that is perfectly fine. We're perfectly content with that. It's a solution. And so if we were even to plug these back in to check our work, we could say the absolute value of 2 equals 2, which is true that 2 is 2 from 0. And if you were to make 2 positive, it's still just positive 2. It's already positive. But if I were to plug in this other one, I get the absolute value of negative 2 is 2. And we know the absolute value makes things positive because it's the distance from 0. And since the negative 2 is 2 from 0, we say that 2 does equal 2, and yeah, that checks out as well. And so both 2 and negative 2 are the answer here, because, once again, both 2 and negative 2 are 2 from 0. And so this is what we were talking about here in step 2 here, where we set the inside of the absolute value, in this case x, equal to both a positive and negative number from the other side of the equation. So we set x, the inside of the absolute value, equal to the positive and negative versions of the other side, which is 2, so we made it equal to positive 2 and negative 2. And if there were still things to solve, more steps to complete to get x by itself, we would do those steps. However, there are no steps to do in this problem because x is already by itself. We'll encounter in problem 3, for example, where that is the case. So on to example 2, I want you to go ahead and attempt this one on your own. So go ahead and pause the video, attempt this, and then restart the video, or resume the video, I should say, after you attempt it. And I encourage you to do that on a lot of these examples, not just this one, but any one that you're like, you know what, I should try this one. I would encourage you that it's going to help you learn to at least make an attempt, even if you're not 100% confident, even if you don't get it right, it's going to help you learn. So on example 2 here, the absolute value of m is 14 or equals 14. And that means m, whatever's inside the absolute value bar, is 14 from 0. In order for that to be the case, it could be 14, and it could also be negative 14. And so those are the two answers. And that's because both 14 and negative 14 are 14 from 0. Or also, like we mentioned, we took what was inside the absolute value bars, so m, and we set it equal to the positive and negative version of that number, or what's on the other side, so 14 and negative 14. And those happen to both be solved. Now, if you wanted to, you could also just box these as one box. That's perfectly fine too. Or you could use those two separate boxes like I did here. You could also write your answer as negative 14, comma 14, and box that, and just make it a list. Typically, if we do make it a list, we just go least to greatest. But if you were to put 14 and then negative 14, that's also fine. So now moving on to number 3 here. If we make our two equations here, we have 5z is equal to 40, and our other equation is 5z equals negative 40, because we're saying whatever's inside the absolute value bars is 40 from 0. So in order for 5z to be 40 from 0, 5z could equal 40 or negative 40, because both scenarios would leave 5z being 40 from 0. Now notice we're not saying that z is 40 from 0. We're saying 5 times z is 40 from 0. A very important distinction that I want to make here as well. Now I have to do step 3, where I have to solve both equations. So this first equation on the left, I have to solve, I have to get z by itself. And how I would do that is I undo the multiplication of 5 by dividing by 5. And if I divide one side by 5, I divide the other side by 5, and I get z to equal 8 as one of my answers. Now that that one's solved, I'm going to go ahead and go on to the next equation here, where I also have to undo the multiplication of 5 by dividing by 5. Now here I get a different answer. I get negative 8 as my other answer. And so z happened to be 8 and negative 8 here on this problem, because when z is 8 or z is negative 8, we end up getting something that is 40 from 0, which is either 40 or negative 40 when we plug it back in. And you could always, once again, check your work, just like we did on example 1, by plugging them back in. Number 4 here, we have the absolute value. Flip my page there. Number 4 here, we have the absolute value of negative 7a equals 28. Now, even though there's a negative here, we're not in panic or anything like that, because the absolute value still equals a positive, so we're saying negative 7a equals 28. And so we actually don't do anything with that negative for a while until we get to step 3. Okay, but there is no step 1 here because the absolute value is isolated. Once again, I'll explain what it looks like for it to not be in a little bit. But what we're going to do is we're going to do negative 7a equals 28, the positive version of the other side of the equation, and negative 7a equals negative 28, the negative version of the other side of the equation. And I keep those 7a's negative, okay? It doesn't just automatically become positive when we make these two equations, because once again, we're saying it's the distance from 0, and so we're trying to say that negative 7a, specifically the whole thing, including the negative of the negative 7a, is 28 from 0. So that could either be it equaling 28 or negative 28. Now, in an effort to solve these equations as we enter step 3, previous was on step 2 to make the equations, I have to undo the multiplication of negative 7 by dividing by negative 7. And as I do that, I get a to equal -4. And it's perfectly fine that I get a negative here like I have been earlier, because if I plug in -4 here, I have -7 times -4, which is positive 28, which is 28 from 0. If I solve this other one by dividing by -7, I end up getting a equals positive 4 in this case. And 4, if I plug that back in here, I get -28 by multiplying by -7, and -28 is 28 from 0. Because once you put in the absolute value bars, a number in the absolute value bars, you end up getting it out as a positive at the end. So that would be the answers for number 4. Now, number 5 here, we have the absolute value of d plus 1 equals 8. I just want to further explain what it would look like for it to not be isolated, for the absolute value to not be isolated, because the variable is not isolated, but the absolute value bars are isolated. And for it to not be isolated, it would be like if you had 3 times the absolute value, 3's outside the absolute value and doing something with that absolute value expression. Where if I were to have, or maybe like divided by 3, okay, that's also not by itself, not isolated yet, so I'd have to undo that. Or if I were to have 3 plus this absolute value, or 3 minus the absolute value, or the absolute value minus 3, or plus 3, or anything of those natures where there's something outside the absolute value bars on that same side of the equation. That's when we have to still isolate the absolute value bars before continuing to step 2. But since that's not the case, we just skip step 1 here, essentially noting that we don't have to, and then move on to step 2 by making our 2 equations, which is d plus 1 equals 8, and d plus 1 equals -8. And then now I solve each equation, and both equations I have to subtract by 1 to solve, because both equations are the variables being added by 1. So if I subtract 1, I end up getting d equal to 7. And if I plug that back in, I get 7 plus 1, which is 8, and 8 from 0. And if I subtract 1 of the other equation, I end up getting d to equal -9, which if I plug in up here, I get -8, which is also 8 from 0. So that's my answer. So those are my 2 answers, 7 and -9. Moving on to number 6 here, the absolute value of w minus 3 equals 4. So since the absolute value bars are isolated, nothing outside of it, we are going to go ahead and make our 2 equations. W minus 3 equals 4, and w minus 3 equals -4. Solving each equation by adding 3 results in w equals 7 as one answer. And the other equation, we add 3 to both sides, and we end up getting w equals -1. And so it's perfectly fine here on examples 5 and 6 that these numbers are not just a positive and negative version of the same number. So note on examples 1 through 4, it was 14, -14, 2, -2, 8, -8, 4, -4, the same numbers, positive and negative versions. Not the case here on 5 and 6. And that's because we are adding and subtracting with our variable, which causes us to get different numbers, not just different signs, when we are adding and subtracting to different numbers such as 4 and -4, or 8 and -8. On to number 7 here, we have the absolute value of 4n plus 2 equals 34. So the absolute value is still isolated, nothing outside the absolute value there that is doing anything. So we have 4n plus 2. Let me rewrite that n, it didn't write very well, equals 34. And then the other equation, 4n plus 2 equals -34, because once again we're saying that this 4n plus 2 is 34 from 0, and for that to be the case, 4n plus 2 is either 34 or -34. And so to solve for n, we have to first say that since we know that whole expression, 4n plus 2, is equal to 34 or -34, then we can solve those. So I'm going to solve these by undoing the division, or undoing the multiplication and addition, but undoing the addition comes first by subtracting 2. And I end up getting 4n equals 32. And then I would go ahead and divide by 4, and I get n equals 8. Now, some of us may prefer to do what I just did, where you completely solve one equation before moving on to the other equation, whereas some of us might prefer to do the blue step for each equation first, where we subtract 2, and get 4n equals -36, and then move on to the green steps for both equations. So some of us might do first step for first equation, first step for second equation, second step for first equation, and second step for second equation. And really, it's your preference of how you want to solve these, but I typically just do all of one equation. So the second equation, I divide by 4, and I get n equals -9. So my 2 answers are +8 and -9. Now I have number 8 here, and then getting the absolute value of negative 2v minus 5 equals 17. Do not be concerned about the amount of negatives here, because the absolute value still equals a positive number, and so the distance is still able to be 17. We are not concerned about what's inside the absolute value bars at this point. That'll come after we make our two equations, which we are about to do right now. So we end up getting negative 2v minus 5 equals 17, and negative 2v minus 5 equals negative 17. And so now we start worrying or being concerned or even thinking about those negatives, because only now it becomes part of our solving that we have to account for those. And so I have to undo this negative 2 that's multiplying and undo this minus 5 that's subtracting. And so I undo the subtraction of 5 by adding 5. And I end up getting negative 2v is equal to 22. Then dividing by negative 2, I end up getting v to equal negative 11 as one answer. In the other problem here, I add 5, and I get negative 2v equals negative 12, and then I divide by negative 2, and I get v to equal positive 6. Well, I should change colors there to match up to the other problem a little bit better, but regardless of math, we'll say the same, that v equals positive 6. Moving on to the next page here. So here it says, what if there's, quote, stuff outside the absolute value bars, aka things such as this plus 2, or on number 10, this minus 8, or on number 11, this 6 that's multiplying, number 12, a negative 2 that's multiplying. So what happens when there's things outside the absolute value, when there's stuff outside the absolute value, when there's math outside the absolute value on that same side of the equation? Well, we have to do step 1 now from our 3 steps we listed earlier when we crossed out our 4th step. And that's to isolate the absolute value. So on number 9 here, before I make two equations, I have to subtract the 2. If I make two equations early right now, I'm doing it wrong, and I will explain after I solve this problem correctly why that would be the case, why that would be wrong. Okay, so for number 9 here, I have to first subtract 2 to undo the addition of 2, and now I get the absolute value of c equals 10. And so now that the absolute value is the only thing on that side of the equal sign, I'm going to undo, I'm going to make my two equations here to factor in the fact that there's two ways to be 10 from something. You could be at 10 or you could be at negative 10. And now my variable is actually by itself. There's no more math to do because I have c equals 10 and negative 10. And if I were to plug either number back in, I get 10 plus 2 when the absolute value of 10 is 10. So 10 plus 2 is 12. Or if I plug in the negative 10, the absolute value of negative 10 is still 10 because it's 10 from 0 plus 2, which is still 12. Now, if I were to have done this the wrong way, which is something I unfortunately see all too often, where I try to make my two equations right away off this, and I try and do c plus 2 equals 12 and c plus 2 equals negative 12, we're going to get the wrong answers. And I'm going to showcase that right here. And that would happen by subtracting 2. We get c to equal 10, which you're like, well, Mr. Kossel, that's the right answer. We just got that. Well, sure, that's the correct answer. But wait, that's one of the correct answers. But wait until we look at our other problem, which I wrote incorrectly. I put minus 10 there, but that should be a minus 12. Okay? And if I subtract 2 from this equation now, I end up getting c to equal negative 14, which is very much so not that number. And that's because it's wrong. And if I plug in negative 14 back in my original equation, I get the absolute value of negative 14, which is positive 14. And 14 plus 2 is most certainly not 12. And so that doesn't even work. It's not even true because it's the wrong way to do it, because we don't make the two equations until the absolute value is completely isolated like we did here. So now, knowing that's the case, let's move on to these following examples here. And so number 10 here, to isolate the absolute value, we have to undo the subtraction by adding 8. And I end up getting the absolute value of y equals 3. And now I have y equals 3 and y equals negative 3 as I make my two equations. And these equations are already solved for y, so I'm done. Moving on to number 11 here. 6 times the absolute value bars. Well, before I even move on to the other side, I know I have to undo this multiplication by dividing by 6. The 6 is reduced, and I get 1 times the absolute value of x, or just the absolute value of x, equals 4. Now that my absolute value is isolated, I make my two equations that are 4 and negative 4. And these are already solved. So those are my two answers. On number 12, we'll actually have to start doing more work to solve these equations once we make them. And now here I notice that I have a negative 2 multiplying with this. Now it is multiplying, so I'm not going to add 2 to undo multiplication. I divide by negative 2 to undo multiplication. And I end up getting the absolute value of z plus 3. Don't forget it's still an absolute value. As I divide the other side by negative 2, I end up getting that equal to 7. Now I make my two equations since my absolute value is isolated, and I get z plus 3 equals 7, as well as negative 7 in my two different equations. And now as I continue to solve these, I subtract 3, and I get z equals 4. And the other one, I subtract 3, and I get z to equal negative 10. And just like before, if you were to plug in either or both of these answers one at a time, you'd end up getting it equaling the other side of negative 14. Now at number 13 here, our absolute value is being divided. Well, we undo division by multiplying by that number. So I'm going to multiply by 6, or 6 over 1, and the 6 is reduce. And then on the other side, I get the absolute value of 2w minus 4. Note the absolute value is still there. And I multiply both sides by 6, so I multiply the right side by 6, which I get 18. Now that my absolute value is isolated, I can make my two equations and drop the absolute value bars. So you only drop the absolute value bars when you make your two equations, after it's already isolated. Now, I do want to note something I see from a lot of people is I do see this where they choose not to write that, and instead they just write the second equation here and start solving from there by adding 4 and adding 4. And while that can work, I will say that I see a lot of errors when I see students do this. Very rarely do I see a student do this do this instead of writing it all out and get them consistently correct. Very often when I do see students do this, I see them getting consistent errors because of it, or they mess up. And so I would encourage you to still make these two equations after this one, even though, yes, it's extra writing, make it after that one and not just reuse that for your first equation. It sets you up for a lot more success from what I've noticed over the years. So this first equation here, I'm going to add 14 to undo the subtraction first, because that happens before I undo multiplication. And I get 2w equals 32. Dividing both sides by 2, I get w to equal 16. And in the other equation, I'm going to go ahead and add 14 as well. Getting a different number, though, than 32, I get 2w equals negative 4. And so dividing by 2 gives me the number negative 2 as my answer. So I get 16 and negative 2 as my two answers here. Moving on to number 14. Negative 10 times the absolute value of h plus 5 minus 3 equals negative 83. So our absolute value is being multiplied and subtracted. We have to undo both of those. And just like we experienced on the previous problem, after the absolute value was isolated, that we have to isolate this by first undoing the subtraction and then undoing the multiplication. So I'm going to add 3 first and get negative 10 times the absolute value of h plus 5 equals negative 80. Now I have to divide by negative 10, and I get the absolute value of h plus 5 equals positive 8. So I go ahead and make my two equations now that my absolute value is completely isolated, and I get h plus 5 equals 8, as well as h plus 5 equals negative 8. And solving each of these equations results in, after subtracting 5, I should note, h equals 3, and subtracting 5 in the other one results in h equals negative 13 as my two answers. Let's move on to the following example, 15. And I have 7 times the absolute value of 4n plus 8 minus 6 equals 106. Once again, I first have to undo the subtraction by adding 6 to both sides. And I get 7 times the absolute value of 4n plus 8 is equal to 112. Now if I go ahead and divide both sides by 7, I end up getting 4 times n plus 8, the absolute value of that, equals 16. Now, since my absolute value is isolated, I make my two equations. 4n plus 8 equals 16, and 4n plus 8 equals negative 16. I start solving by subtracting 8, and I get 4n equals positive 8. Then I divide both sides by 4, and I get n to equal 2. The other equation, I do the exact same steps, but get different results. So when I subtract 8, I don't get 8, however, I do get negative 24. And then when dividing by 4 doesn't give me 2 then, it instead gives me negative 6 as my other answer. And once again, if you were to plug these numbers back into your original equation, and as long as you do your math correctly, you would note that, hey, they are correct. Moving on to number 16 here, 3 halves times the absolute value of 4r minus 4 minus 24 equals negative 21. So again, multiplication and subtraction. I undo the subtraction first by adding 24. And I end up getting 3 over 2 times the absolute value of 4r minus 4 equals positive 3. To undo the multiplication of a fraction, I don't divide by a fraction because that's crazy messy on the other side and in general. So I multiply by the reciprocal or the flipped version, 2 over 3. On the left, the 2's reduce, and I get the 3's to reduce, and I get the absolute value of 4r minus 4. On the right, I put this 3 over 1, and note that the 3's reduce, and I have 1 times 2 multiplying straight across, which is 2. So now my absolute value is isolated, so I make my two equations. 4r minus 4 equals 2, and 4r minus 4 equals negative 2. In each of these equations, I will begin solving by adding 4. And I get 4r equals 6. And then dividing by 4, I get a fraction which is okay, and that's 3 over 2, or 1.5. So whether you call that 3 over 2 or 1.5 is perfectly fine with me. I don't care. Or you could also call it 1.5, of course. So I'm going to go ahead and add 4. Add 4. I do get 4r equals 2. And once again, I'm going to get a fraction here as a divide, which once again, that's fine. I do want the fraction to be reduced to 1/2 or the decimal 0.5. Now let's talk about some special cases. There's a special case here for 17 and 18, and then I actually want to cover another special case that we don't see listed here because I think it's going to be very pertinent to the homework as well as maybe a test problem. You know, just a thought that might come into play. But you just wanted to bring that up for you guys. Now let's move on to number 17 here. So on 17, it asks us to solve the equation below and then also explain the solution. So here on 17, the absolute value of x is equal to negative 6. So our first instinct might be to do the following, but don't write this down because it's wrong. But first instinct might be to write x equals 6 and x equals negative 6 and do the positive and negative versions of the right-hand side and having the left side, the inside of the absolute value stay the same there. And then we say, oh, they're solved. Goody. Good for us. We got these right. But the answer is that actually that's not correct at all. That is very, 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 very wrong. And the reason why that's wrong is if you were to plug in 6 here, we'd get the absolute value of 6 equals negative 6. And that's saying that 6 is negative 6 from 0, which is not true. That'd be like 6 equals negative 6, which once again, false statement. And if you were to instead of plugging in positive 6 into there, plug this negative 6 in there and think, oh, maybe that'll work. Well, the absolute value of negative 6, last I checked, is still positive 6. And positive 6, once again, does not equal negative 6. So no, this is not correct. And the reason why that neither of these are correct is because the true answer to this problem is that there is no solution. And the reason there's no solution here, which you could abbreviate to SOL at the end, no SOL, the reason it's no solution is because we're saying x is negative 6 from 0, and it's impossible to be negative distance from anything ever. So anytime that the absolute value equals a negative, the answer will be no solution. Now you might be wondering, Mr. Causal, wait a second. We had a number of examples before, such as number 16 and number 14 and number 12, where it equaled a negative right off the bat. And on number 12, it equaled negative 14, for example. Well, I would tell you that, hey, you're right, it did. However, it wasn't just the absolute value equaling that negative. It was the absolute value and something else with it. So once we got the absolute value by itself, it equaled a positive. And that's why it turned out differently. And that would also be true on 14 and 15, that by the time we got the absolute value by itself, it no longer equaled a negative, it equaled a positive, so it wasn't a concern. So it's not a concern if the absolute value equals a negative right away, or if there's equal to a negative right away, but it is a concern is if once the absolute value is by itself, which it starts out that way on 17, if once it's by itself it equals a negative, there's no solution because the absolute value is distance from 0, and that'd be saying that x is negative 6 from 0, which is impossible. So as we look at number 18, we're like, oh, goody, 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 this equals a positive 21. This is normal. Well, we undo the multiplication by dividing by negative 3, and as we do that, we now get the absolute value of 2x plus 1 equals negative 7. Since the absolute value equals a negative number, it is no solution. So even though here it started off equaling a positive, and we're like, oh, good, actually not good at all, because when we got the absolute value isolated, it equaled a negative, and that'd be like saying 2x plus 1 is negative 7 from 0, and having a negative distance is simply impossible. And I mentioned I was going to throw in an extra example because that might come in handy, but before we do, let's explain what happened here. So once again, the reason why both of these have no solution is that distance can't be negative, and quick reminder that absolute value is distance from 0, and thus absolute value cannot equal a negative number. Now I mentioned there was originally going to be an extra example. We actually ended up weaving in 2 examples here, number 19 and 20, into the notes more formally. So here those are. So what happens when the absolute value equals 0 specifically rather than just equaling a negative number? Well, it goes back to saying what is absolute value. It's distance from 0. So we're saying here x is 0 from 0. Now, how many ways are there to be 0 distance from anything? Just one way. You are at the thing. If I am 0 distance from a restaurant, I am at the restaurant. There's no other way for that to happen. It's not like I can be 5 steps north and 5 steps south, and I'm now 5 steps away from the restaurant. Either direction. 0 distance or 0 steps or 0 feet or whatever from anything means you are at the thing. So 0 from 0 means you're there. And so when you're doing this, you only have one case instead of 2 cases. So we just drop the absolute value bars and set it equal to 0. And that's once again once the absolute value is isolated. And so this ends up already being solved, that x is just equal to 0. If we journey over to number 20 here, we can't drop the absolute value bars yet. We first have to isolate it by getting rid of this positive 7. So we'll do that the same way we have previously, where we subtract 7 from each side. And we end up getting the absolute value of 3x plus 12 is equal to 0. And so now we have that 3x plus 12 is 0 from 0, which means it has to be at 0. So you only have one equation rather than 2 as we drop the absolute value bars, because you can't have a positive and negative 0 anyway. 0 is neither positive nor negative. And now I just solve this one, so I subtract 12. 3x equals negative 12. And then I'm going to move this up here so I have room. 3x equals negative 12. Again, I just rewrote it. And now I'm going to divide by 3. And I get x equals negative 4. And so that ends up being my only singular answer. And once again, it's okay for the x to be equal to a negative as long as the absolute value doesn't equal a negative. But here, since the absolute value equaled 0 when it was isolated, we only had one equation and thus one solution. And our explanation again for this is that there is only one way to be 0 distance from 0. Now it's true that there's only one way to be zero distance from anything, but for absolute value, we're specifically talking about the distance from 0. So that wraps up here section 3.4 of Algebra 1.